Friday's class, we're going to start with this question. Why do balloons stick to walls, right? You know, you've probably seen this. You rub a balloon against your hair or a sweater, and you can stick it to the wall. And so we wanted to see what you would come up with as an explanation. Okay? So today's class is going to be on static electricity. And so you need to think about, how does static electricity work? Does rubbing a balloon against your hair change it so that it can then stick to the wall? And you probably know something about it, so start there. Well, after that, you can see, again, we're going to be talking about how electric forces are made, and we're going to watch a video. Okay. The first thing we're going to be doing is watching a video, a Bill Nye video, and I'll have the link to that in the module after this video. Okay. So you'd be watching a video, it's about 20 minutes long, of Bill Nye talking about static electricity. And if you were watching this, you should probably go pause this video and go open that one and watch it. Now, we want to have some notes as well, and it's important, and we talked about this on Tuesday, if you'll recall, that atoms are composed of charged particles, right? You probably remember that we were talking about this, and we said we have things like particles in the nucleus or in the center of the atom, right? So we have our, right, protons, right, and our neutrons, right, in the nucleus, right? So we have protons and neutrons in the nucleus, and then around the atom, right, in orbit, we have electrons, right, orbiting the nucleus, right? And so we might have an atom like this, and you've probably seen stuff like this. This is a Bohr diagram, and you probably might remember this from like chemistry class, where you have electrons orbiting around a nucleus that has protons and neutrons. Okay, so just to point out that we're talking about electrons, right, protons, neutrons, and the nucleus. Right? And so when we're doing this, the electrons would be these guys, right? The protons and neutrons, right, are then in this thing, the nucleus. So the nucleus would be just the center part of the atom. Okay, so you've got this model. Now, when we did this on Tuesday, a lot of you guys, instead of drawing it this way, drew something more like this, where you had your, Control Z, where you had Control Z. I feel like, oh, I see, there must be something hidden here that I can't see. Try not drawing there. So it's up here. Okay, good. So we'll draw down here. Right, a lot of you guys drew something like this, where you had your nucleus, right? And then you had, let's add one more particle there. And then you had your electrons orbiting in circles around it. Whoa. Like this, possibly. Right. You can see that my drawing with a mouse is not the greatest, but you had your particles orbiting the nucleus, so you had something of this ilk. Okay. And this might look familiar too. That's actually kind of just a hideous drawing. Let me see if I can do better. It's just bugging me. So you had something like these electrons, right, orbiting the nucleus. Whoa. Right. Right. And so you had some picture like this. But these pictures are not different, right? We still have the nucleus, we still have the electrons orbiting, we still have protons, neutrons, electrons, okay? So whichever model you have, this works well for us, okay? One thing we need to remember is that the electrons are negative, they're on the outside, right? Electrons are negative and on the outside, protons are positive, right? They're on the inside, and neutrons are neutral, but they're also on the inside. Other things that we might get from this, possibly, is that the neutrons and protons are heavy and the electrons weigh very little. So, right, electrons are easily moved around, mainly because they're on the outside and they're held on much more weakly than the protons and neutrons are. Okay. What are the two charges, right? And as we say, electrons are negative, right? So we have negative electrons, right, orbit the nucleus, right, so they're outside and they're low mass, right. Then over here we have our positive protons, right, they're in the nucleus, right, they're held on tightly, right, and they have high mass, right? So you have positives and negatives, and the electrons are the things that are going to be outside where they can move around. Okay. Now, how can I make this atom? How can I make this atom? My theory is that there's another word, like how can I make this atom negative, or how can I make this atom positive? That may not have shown up in my version of this. So I'm going to put a negative sign here and a positive sign here. Okay. If I want to make this thing, right now it's neutral because it has a positive 10 here, but it has 10 electrons. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One of them is in the wrong place. So it has 10 electrons now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we've got 10 electrons and we've got positive 10 protons, right? How do we make this atom negative? Well, all I have to do is drag an electron over here, right, or 2, and now the overall atom, right, is 10 minus 11, right? So it's 10, right, positive 10, oops, minus 11 negatives, right, equals negative 1, right? And so its overall charge is negative 1. However, if I take electrons away, right, and possibly it'll let me, right, if I take electrons away, and I put a couple up here, right, now I can have a positive charge. Now it doesn't look all that positive, except if you start counting, you realize I have plus 10 minus, oops, minus 9, right, equals positive 1, okay? And so notice that I can determine whether the charge is positive or negative by moving electrons, okay? I'm not actually moving any protons. If I add electrons, I can make something negative. If I take electrons away, I can make something positive. Another thing that we need to get in this unit is that like charges repel, right, and different charges attract, right? And so that's going to be the important thing here. like charges repel, and opposite charges attract. That's important because that's what holds atoms together, but it also means that when we have oppositely charged objects, they're going to draw together, and like charges, things will be pushed apart. Okay. Now, if we're talking about, scuffing along on a carpet, right, we know that the electrons actually move from our socks to the carpet. We talked about this on Tuesday. But if we have a balloon that we've scuffed so that it picks up negative charge, right, now that we know that opposite charges attract and like charges repel, we can bring it near a wall, and those walls charge it. The charge on the wall will actually move. Okay. Now, before we actually look at this, let's actually take a look at a video on this. And again, I'm not certain I can call this up just by clicking on this link on my computer, but I can call it up from the actual Google Drive. And here's a quick video clip.
One of the classic demonstrations in electrostatics is using a balloon and simply rubbing it across your head, and very quickly it becomes charged. In fact, if I lift it off my head, I can feel my hairs being attracted to it.
Now, one thing I would like about this is that if he's rubbing the balloon on his hair, right, we said that electrons go onto the balloon, okay? Well, they took electrons from his hair, right? So his hair lost electrons and became positive. The balloon gained electrons and became negative. So the balloon has a net negative charge now, and his hair has a net positive charge, and you can see that the opposite charges are attracted. Okay, so that's one thing that we get from this video. It's a demonstration of that.
The balloon has become negatively charged. It's taken electrons from me, and my hair, of course, has given up electrons, so it's a little bit positively charged, and so they're attracted. But if I take the same balloon and I put it on the wall, well, let's see what happens. It stays there, but I haven't done anything to the wall. So the question is, why is it staying there? The process is actually called induction. Now, when I rubbed that balloon on my hair, I gave it a negative charge, but the wall is actually an insulator, much like the styrofoam cup is. Now, if I take this glass and I rub it with Orlon, I'm going to give it a charge, and watch what happens when I bring it near these small pieces of foam. Now, what makes it an insulator? Well, their electrons in their atoms are bound up, and they're not able to escape very easily. The atomic theory tells us that the nucleus is positively charged, surrounded by electrons which have an equal amount of negative charge. When a positive charge is brought near these atoms, the electrons shift over and are attracted to that positive charge. This process is called polarization. It's the electrons moving closer to the positive charge, but don't actually leave the atom. When we remove the positive charge, the electrons will balance themselves out again, and if we bring a negative charge near that same insulator, it's going to drive the electrons away to the opposite side of the nucleus, allowing the positive charged nucleus to be attracted to the negative charge. We remove it, and once again, the electrons will balance themselves out.
Okay. So, if we were to look back at our picture here, we would assume that what would happen is that the electrons, right, because the balloon is coming closer, will move farther away, okay? And one way of representing this, although they wouldn't actually leave the atom, one way of representing this would be to simply have them move towards the edges. Now, they would actually just move within the atom farther away, right? But if they move away from the balloon, we're left with a net positive area, right, close to the balloon, and a net negative area far from the balloon. And that means that there's going to be an attraction, right? So it's going to be attracted because it's pushed the negative charges farther away, and the left behind these positive charges, which don't move Because they're in the nucleus, right? And they stay where they are, and the balloon can then stick to it. Okay. Now again, though, the electrons don't really move this far. They simply move sort of to the other side of the atom, but this is a good picture of it. Okay. All right, so the last thing we would close with is how can you explain balloons sticking to the wall, right? And since we've explained it and Bill Nye's explained it, I bet you can explain it. Okay. And that would be the end of our class. So yay us.